Hi, I'm Duri, and today I'm going to be talking to you about my honors thesis, which aims to create a solution for students who are facing difficulty when writing documents. So here you can see the playback of a document of a student who is struggling during a field study that I conducted as part of this thesis. You can see that she deletes and retypes the same segment of her paper multiple times, and although this playback is sped up for viewing purposes, it took her over 10 minutes to type this segment. So my question was, how can we help students like this who might struggle disproportionately with writing and spend hours on an assignment only to receive a poor grade at the end? So there already exists a number of different tools to help students with writing. There are a number of different natural language processing tools that are actually very sophisticated that help students by automatically correcting spelling and grammar errors. However, these tools can be limited in their accuracy, and they can also overlook other types of difficulties that students might face, like content-related difficulties. So when these tools fail, students can always take the initiative and go speak with the professor in person. However, this requires time and initiative, and a lot of students are either too busy or too shy to go do this. So for students who can't visit a professor in person, there exists asynchronous collaboration systems, which provide students the ability to receive feedback from a remotely located instructor. However, this feedback is not immediate. So for immediate feedback, there exists synchronous collaboration systems, in which a teacher and a student can work within the same document and participate in collaborative writing and revision. However, for a teacher to notice that a student is facing difficulty in this sort of environment, the teacher has to be watching the document, which is very time-consuming and obviously not scalable for even a small classroom environment. So how do we provide students with real-time, scalable solutions for all of their difficulties when writing? The solution, a mixed focus system, is an interaction mechanism in which individual and group work can occur at the same time. Students and teachers can work in parallel on their own individual projects, only coming together to collaborate when a specific event occurs. Ideally, this event would be triggered by the student facing difficulty. So there already exists a algorithm that predicts when students are facing difficulty when programming, and it generates these predictions automatically. It's called ECLIPSEHELPER, and it is an Eclipse plugin, and it automatically generates predictions for student programmers. So inspired by these mixed focus systems and the ECLIPSEHELPER difficulty inference algorithm, I decided to create my own architecture for students who are facing difficulty while writing. This architecture attempts to predict when students are facing difficulty automatically, but it also offers the option for students to indicate that they're facing difficulty manually by pressing a button. Once difficulty is indicated, either manually or automatically, a teacher will be notified via an email. Then, once the teacher is notified, the teacher can go into the collaborative writing system and assist the student in real time. So now that we kind of have an idea of the architecture that we want, my next question was, how do I go about implementing this, and what sorts of features does an architecture like this need? And there were 3 different features that I really identified as being important for a mixed focus collaborative writing architecture. The first is a mechanism for inferring difficulty. And the second was an ability to notify the teacher once this difficulty has been predicted. And then finally, there needs to be a way to facilitate conversation and communication between the teacher and the student so that this difficulty can then be resolved. Now, none of these 3 things are new, and there already exist tools for inferring difficulty, notification, and for conversation and collaboration. So my question was, how can we reuse existing tools in order to create a new architecture? So the first tool that I sought to reuse was a difficulty inference algorithm, and I chose ECLIPSEHELPER for this. And ECLIPSEHELPER makes inferences and predictions based on aggregated command ratios. So when the user enters a command, such as typing a character or navigating between classes in Eclipse, these commands are then mapped to larger command categories like edit, focus, navigation, and debug. Once they're mapped to these categories, after a certain number of commands have been collected by the algorithm, then the algorithm looks at the ratio of the number of commands in each category to the total number of commands that have been collected in this segment. Then these ratios are passed into the algorithm, and a prediction is made based on them. So the second tool that I wanted to incorporate in my architecture was a collaboration and communication system within a writing environment. And I chose Google Docs for this for several reasons. First of all, Google Docs is widely used by students of all ages, and so I thought that using this environment would make my tool more accessible, and the learning curve would be minimized for students who are trying to learn a new piece of technology. In addition, it has been shown that software agents are often more effective when they're presented as peer companions, because receiving feedback from a peer rather than an instructor reduces anxiety and fear of failure. So I thought that I hypothesized that presenting my tool and presenting an instructor's help through Google Docs would make students more comfortable working with an instructor and more comfortable working with my tool. And finally, I chose Google Docs because of easy implementation, as I was able to create a Chrome extension to track document revisions. So in summary, I combined the ECLIPSEHELPER difficulty inference algorithm with the collaboration and communication architecture of Google Docs in order to create a new architecture that allows for mixed focus collaboration. And I had to make a couple different, and so this architecture works by taking commands that are entered into a Google Doc and then mapping them to the ECLIPSEHELPER command categories, and then feeding them into the ECLIPSEHELPER algorithm, which then generates a prediction, which is sent back to the student, and it's also sent, the teacher is notified if the student is facing difficulty. And so I had to make a couple different modifications to the ECLIPSEHELPER algorithm in order to make this, this merger work. So the first thing is that ECLIPSEHELPER was originally designed for individual use, and so I had to create a server in order to allow multiple users' work to be and data to be processed at once. I also had to make adjustments to the command mapping and to the prediction parameters of ECLIPSEHELPER to specialize it for document-related difficulties. So now that I'd created this architecture, I had a lot of new questions about whether this would really be practical in a real-world environment. You know, would students appreciate receiving unsolicited help, or would they find it like unnerving or annoying? Would like this ECLIPSEHELPER algorithm prove to be successful in programming environments as well as document environments, or would it really just prove to be useful in programming environments? Would my tool be like usable for students, or would they find it difficult? And then finally, my other question was whether students would even want to use this tool. Would they be enthusiastic about it, or what? And so to answer some of these questions, I conducted a field study. My mom teaches political science at a 2-year community college, and I enlisted students from from 2 of her classes to participate in this study. And I gave them each an assignment that was already assigned for their class. It was a 2-page paper on Social Security, and I had them complete it within the environment that I'd created. And I acted as the instructor, going in and helping them out when they needed help. And I chose these students because originally, when I was originally inspired to do this study because my mom has always talked about how she has students who try really hard in class, but still do really poorly on writing assignments. And a lot of her students work full-time jobs and are taking care of kids in addition to school. And she has a lot of non-native English speakers in her class. And I thought that this was the perfect target audience for my tool because it aims to help students who are facing difficulty while writing, but may not have time to come in, to office hours, every week. So in order to gain sort of a qualitative assessment of how my students, or how the students liked using the tool, I asked them a couple of different questions in a survey afterwards. First, I asked them about whether or not they appreciated the unsolicited help that came through, or how they felt about it. And overwhelmingly, all of the students felt really positive about the help. They really appreciated the assistance, and nobody seemed to have any sort of like privacy concerns or find that it was like irritating to receive the help. I also asked the students about how usable the tool was and whether it was easy to use or difficult. And of the 6 students who successfully participated in the study, they all said that the tool was either very easy to use or somewhat easy to use. However, there were 12 students who originally signed up for the study that didn't end up completing it. And while some of these students might not have completed it because they just didn't do the assignment at all, there are also at least 3 of them I know, and maybe others, who struggled with like the installation process of the tool. And so I think this is something to consider that I didn't originally consider when creating the study. In future studies with classes of students who aren't necessarily super familiar with using new technology, is making kind of the inroad a little bit easier for them to pave the way for people who might be enthusiastic about the tool but not feel super comfortable with a new technology. So to add to my qualitative results, I also created a chart here of kind of quantitative results from the study. So in the first row is the numbers of times the algorithm predicted difficulty for each student. And as you can see, it's very small. I'm going to talk about that more in the next slide. The second row shows the number of times the student manually indicated that they were facing difficulty. And as would be expected, different students faced different amounts of difficulty while they were writing. The third row shows the total number of predictions made, which most of these, again, were making progress predictions because there weren't very many difficulty predictions made. And finally, the last row shows the number of times I offered help for each student. And so I tried to offer help for each student, once upon when they started writing, just to let them know I was there and how to use the tool. And then I came back in and offered them help each time they indicated that they faced difficulty. So going back to the infrequent difficulty predictions, this was one of the major limitations that I found through my study, and I think it resulted from a number of different reasons. The first is that a 2-page paper is a very different beast than a programming assignment, in that it's a lot shorter and it's a lot less of a command-rich environment. And I tried to make adjustments for this in my original prediction parameters, but I think further adjustments need to be made after completing this study. Also, you can see a chart here of the different commands that I mapped to different categories within the algorithm. And there are a couple different issues with this command mapping that I think might improve the algorithm in the future. The first is that ECLIPSEHELPER places a lot of weight on the debug category in predicting whether students are facing difficulty. And I mapped a lot of revision-based commands to the debug category. However, I noticed that most of the students who did the writing assignment did not actually revise their writing assignment once they were done. They just kind of wrote it and then they were finished. And this was something I didn't take into consideration. They might not, have learned about that stuff in the writing process, or it might just be a 2-page paper and they didn't care. And so I think that's something to take into consideration in future studies. Figuring out how to map to the debug category when students aren't revising, their papers. In addition, I mapped both insert and delete to the edit category, but there's another command mapping that can map insert to the edit category and deletes to their own category, and I think this command mapping might have been more successful. In addition, I noticed that periods of inactivity when I was watching the document playbacks kind of corresponded to points when the students felt they were facing difficulty, and this isn't the case in ECLIPSEHELPER because ECLIPSEHELPER thinks that periods of inactivity indicate that the student is distracted or working on something else. But I noticed that most of these students, because it was such a short writing assignment, sat down and wrote the whole thing in one session, didn't really get distracted, and so that mapping periods of inactivity would more closely correspond to when they're facing difficulty rather than when they're working on another task. So to summarize, I just want to talk about some of the key contributions that I've made through this work. The first is that I came up with the idea of a mixed focus, difficulty-triggered collaborative writing environment, and then I implemented this architecture that I'd conceptualized. Finally, I conducted a field study that evaluated my architecture, and from this field study I found that students found the tool I created really helpful and they were really enthusiastic about using it. However, there are some key differences between programming and writing that proved to be limitations in the actual difficulty inference algorithm. However, more important than either of these two results is the fact that I have now generated an initial set of user data, and we have a test bed now that can be used to rerun experiments on this and refine the algorithm. So we can try out different command mappings, we can try out different prediction parameters, and we can train the algorithm for future use. And you can also see a picture here of a visualizer tool that I've developed that helps researchers to visualize the different command ratios that generate a prediction within ECLIPSEHELPER. And so using this tool as well as other tools that I've developed and the work that I've done on this thesis, we have kind of created the basis for working out and training a difficulty inference algorithm for writing. Thank you. Yeah.
What was the installation process that the students are having difficulty with?
Well, it was something that I didn't think was very difficult, but I think they found it more difficult than I did. It was essentially they just had to go through and install a Chrome extension. But a lot of students had confusions that I didn't initially think that anyone would have. Like, I provided them with a Google Doc to do their work in, and they did their Google Doc in another Google document. Or some students wrote their paper in Microsoft Word and then copy and pasted it into the Google document. So there were a number of different small misunderstandings that I think could be worked out in a future study where perhaps we gave them a week to work out their difficulties and then started the study. I think that would be beneficial.